For any help regarding magnetic materials assignment help, visit https://www.eduassignmenthelp.com. Email info@eduassignmenthelp.com. Call us at +1 678 648 4277. Electromechanics Assignment Help. Incompressible, inviscid fluids. Depth W into paper figure 12p.3 equals 0. 12.3. A magnetic rocket is shown in figure 12p.3. A current source 10, distributed over the depth W, drives a circuit composed in part of a movable piston. This piston drives an incompressible, inviscid, non-conducting fluid through two orifices, each of height d and depth W. Because dd, the flow is essentially steady. A. Find the exit velocity v as a function of 4. B. What is the thrust developed by the rocket? You may assume that it is under static test. eduassignmenthelp.com. For Section 7.2, Prob. 7.2.1 in Sector 3.7, CI is defined such that in the conservative subsystem, EQ 3.7.3 holds. Show that AI satisfies EQ 7.2.3 with P plus AI. Further, show that if a specific property C is defined such that by pi, then by virtue of conservation of mass, the convective derivative of C is 0. For Section 7.6. Prob. 7.6.1 show that EQ, HB of Ta 1P7_6_2 is correct. Prob. 7.6.2 show that X, J, and 2 from Table 7.6.2 are correct. Prob. 7.6.3 A pair of bubbles are formed with the tube valve system shown in the figure. Bubble 1 is blown by closing valve V2 and opening VL. Then, VL is closed and V2 opened so that the second bubble is filled. Each bubble can be regarded as having a constant surface tension Y. With the bubbles having the same initial radius EO, when T equals 0, both valves are opened, with the upper inlet closed off. The object of the following steps is to describe the resulting dynamics. A flow through the tube that connects the bubbles is modeled as being fully developed and viscous dominated. Hence, for a length of tube K having inner radius R and with a viscosity of the gas, the volume rate of flow is related to the pressure difference by eduassignmenthelp.com. The inertia of the gas and bubble is ignored, as is that of the surrounding air. Find an equation of motion for the bubble radius E1. B. With the bubbles initially of equal radius EO, there is a slight departure of the radius of one of the bubbles from equilibrium. What happens? C. In physical terms, explain the result of B. For Section 7.8. Prob. 7.8.1 A conduit forming a closed loop consists of a pair of tubes having cross-sections with areas AR and I. These are arranged as shown with a fluid having density Pb filling the lower half and a second fluid having density Pa filling the upper half. The object of the following steps is to determine the dynamics of the fluid, specifically the time dependence of the interfacial positions air and E. A. Use mass conservation to relate the displacements air, E, to each other and to the fluid velocities, Vr, Vk, on the right and left respectively. Assume that the fluid is inviscid and has a uniform profile over the cross-section of a tube. B. Use Bernoulli's equation, EQ, 7.8.5 to relate quantities evaluated at the interfaces in the lower fluid and in the upper fluid. C. Write the boundary conditions that relate quantities across the interfaces. D. Show that these laws combine to give an equation of motion for the right interface having the form eduassignmenthelp.com. Prob. 3.10.3 Fig. P 3.10.3 shows a circular cylindrical tube of inner radius A into which a second tube of outer radius B projects halfway. On top of this inner tube is a blob of liquid metal, shown inside th broken line box, having an arbitrary shape, but having a base radius equal to that of the inner tube. The outer and inner tubes, as well as the blob, are all essentially perfectly conducting on the time scale O interest. When T equals 0, there are no magnetic fields. When T equals O+, the OUT tube is used to produce a magnetic flux which has density Bo Za distant 2 above the end of the inner tube. What is the magnetic flux den ity over the cross-section of the annulus between tubes a distance 2a, below the end of the inner tube? Sketch the distribution of surface current on the perfect conductors, outer and inner tubes and blob, indicating the relative densities. Use qualitative arguments to state whether the vertical magnetic force on the blob acts upward or downward. Use the stress tensor to find the magnetic force acting on the blob in the z direction. This expression should be exact if 2a, and be written in terms of a, b, Bo and the permeability of free spatio. eduassignmenthelp.com. Prob 3.10 point for the mechanical configuration is as in Prob 3.10.3. But, instead of the magnetic field, an electric field is produced by making the outer cylinder have the potential Vo relative to the inner one. Sketch the distribution of the electric field, and give qualitative arguments as to whether the electrical force on the blob is upward or downward. What is the electric field in the annulus at points well removed from the tip of the inner cylinder? Use the electric stress tensor to determine the z-directed electric force on the blob. +4. Prob 3.10.5 in an EQS system with polarization, the force density is not F equals PPE plus PFA, where PP is the polarization charge. Nevertheless, this force density can be used to correctly determine the total force on an object isolated in free space. The proof follows from the argument given in the paragraph following EQ 3.10.4. Show that the stress tensor associated with this force density is. Show that the predicted total force will agree with that found by any of the force densities in Table 3.10.1. Prob 3.10.6 given the force density of EQ March 8, 13, show that the stress tensor given for this force density in Table 3.10.1 is correct. It proves helpful to first show that. Prob 3.10.7 given the Kelvin force density, EQ March 5, 12, derive the consistent stress tensor of Table 3.10.1. Note the vector identity given in Prob 3.10.6. eduassignmenthelp.com. Prob 3.10.8 total forces on objects can sometimes be found by the energy method ignoring fringing fields and yet obtaining results that are exact. This is because the change in total energy caused by a virtual displacement leaves the fringing field unaltered. There is a theorem that any configuration that can be described in this way by an energy method can also be described by integrating the stress tensor over an appropriately defined surface. Use X. March 7, 22 of Table 3.10.1 to find the force derived in Prob 2.13.2. For Section 3.11. Prob 3.11.1 an alternative to the derivation represented by EQ 3.11.7 comes from exploiting an integral theorem that is analogous to Stokes's theorem. 1. eduassignmenthelp.com